All right, so we spent some time reading through that first little section of defined statistics and statistical thinking. And let's just discuss for a little bit, like, what is statistics? What are we going to learn in this class? What's your, takeaway summary?
Numbers.
Numbers, okay. What kind of numbers?
Ratios.
Okay. What else? What's specific about these numbers compared to the kind of numbers we were learning about in algebra class?
Do you have, different answers?
Yeah, you're going to have some, it starts with a V. What's the vocabulary word maybe that started with a V that we could see? Variability, very good. So our statistics that we're going to get, these numbers we're going to get, have variability. We're trying to decide with statistics how confident we are that our variable answers are going to be great. Here's some things that I want to point out to you just in this reading in case you didn't get it. We obviously have the definition of statistics here. It is a science. It is an entire course of science is a statistics class. But there's 4 parts of statistics here. We have the first part, which is data collection. The collection of information. Our second part is organizing and summarizing this information. We need to then analyze to draw conclusions about this information. And our fourth part is some measure of confidence, or how convinced we are that that information and our conclusion drawn from the data is accurate to real life. Those are basically the 4 sections we're going to hit on in this class. Our first chapter is going to be about that data collection and why data collection is a very important, often misunderstood part of the statistical process. When we're talking about data, remember we're talking about a fact or proposition used to draw a conclusion or make a decision. Data can be a numerical or non-numerical, but it describes characteristics of an individual. This is probably a really important sentence. I probably should have bolded it. Because data are powerful, they can be dangerous when misused. So there's going to be in your life, a lot of times you're given a statistic of something that is used to misinform you in some way, whether that be to convince you to buy a product or to eat a certain way or be a certain way. A lot of statistics are misused unless you understand what you're looking at when you're provided with analyzed data and conclusions from data. So our goal in this class is to make you a better consumer of information, to understand the statistics that you're being shown. A couple more vocabulary words that are floating around in here. We have the lurking variable. Does anyone want to try to describe that one without reading it straight off the page? What is a lurking variable?
It's like a false statement that people believe, kind of like a stereotype.
Yeah, kind of. That's a good way of putting it. So it's like we're looking at one thing to assume that it's something, and then in fact, there's this other variable that's actually influencing what we're looking at more so than what we're looking at. Cool. And last but not least on this page, variability. I should have bolded that one as well. You guys already answered that question for me, but we are looking at things that vary, that change. So in algebra class, our variables had finite answers. They had actual answers. In this class, we're going to eventually start to have ranges of certainty with how we think our information and how confident we are, in that information. That is our end goal with statistics. So let's hop into the process of statistics. Let's say you're walking down the street and you notice that a person walking in front of you drops $100. Nobody seems to notice the $100 except you. Since you could keep the money without anyone knowing, would you keep the money or return it to the owner? So let's suppose we wanted to use this study to gauge the morality of students in your school by determining the percentage of students who would return the money. How might we decide to run this experiment? A poll, okay. Love, we could present this poll to every student in the school. Are we going to get all 3,000 whatever kids in our school to answer this poll? No. That would be really difficult or impossible if the student body is large, like it is at our school. What's a second possibility that we could do?
Survey.
Just pick 50 kids. Pick 50 kids and ask them to give a statement about the school. So what we have learned here is that there is a difference between what's called a population. That would be the entire school. All Mesquite High School students is the population we're studying here. An individual is an individual person or object in a member of this population. But if we just get a small subset, so just these 50 people we're going to study, that's called a sample of the population. So population is everything. Sample is something smaller, like a small subset of the population, and an individual is an individual within that sample in the population. So in this $100 study, like I said, the population is all students, each student is an individual, and the sample is the 50 students selected to participate in the study. Let's suppose that when we asked these 50 kids if they would return the money, 39 of the 50 said that they would return the money. We could present this result by saying that the percentage of students in the survey who would return the money to the owner is 78%. Check, done. That is called a descriptive statistic because it describes the results of the sample without making any general conclusions about the population. So a statistic is a numerical summary of a sample, 78%. Descriptive statistics specifically consist of organizing and summarizing the data. Descriptive statistics describe data through numerical summaries, tables, and graphs. So 78 is a statistic because it's a numerical summary based on a sample. Descriptive statistics, I'm going to stutter over that word all semester long, make it easier to get an overview of what the data are telling us. But if we take the 78% of our 50 sample size and we apply it to the larger population and say that 78% of all Mesquite High School students would return the money, we are then using what's called inferential statistics. It uses methods that take a result from a sample and extend it to the population and eventually measure the reliability of that result. Now, this generalization always contains uncertainty because a sample cannot tell us everything about a population. So instead of just saying 78% of all students would return the money, we would actually say a statement like we are 95% confident that between 74 and 82% of all students would return the money. And that's written on the side. I forgot to flip the page. Sorry, it's on the next page. We give this confidence rating for an interval. So our number 78 is smack in the middle of this. It's in the middle of 74 and 82. So we're pretty confident that since we took a survey and got 78, that most students or all students in the population that would return the money is between 74 and 82%. So this inferential statement now includes a level of confidence in our results. One goal of inferential statistics is to use statistics to estimate what are called parameters. So a parameter is a numerical summary of a population. So here's what I need you to remember, is a parameter is for a population. Parameter, population. Where earlier we had a statistic that was for a sample. Parameter, population, statistic, sample. Those are the descriptions of the two different things. Numerical summary of a population is a parameter. Numerical summary of a sample is a statistic. Do you see the difference? Okay, so let's just make sure we actually do see the difference between parameter versus statistic. Is the following statement a parameter or a statistic? 48.2% of all students on your campus own a car. Is that a parameter or a statistic? Are we dealing with the entire population or a subset? All students on our campus. Is that the entire population? Yeah. Yes, this is a parameter. Second sentence says, suppose a sample of 100 students from your campus is obtained, and from the sample we find that 46% own a car. Is that a statistic or a parameter? Statistic, because we have a sample. Is that the lunch one? Okay, bye, have lunch. Part C says, suppose the average salary of all employees in the city of Joliet is $78,302. Is that a parameter or statistic? Why is it a parameter? Yeah, parameter because it's all the entire population of employees. Suppose a sample of 30 employees from the city of Joliet is obtained. From the sample, we find the average salary is $75,038. What is that one? Statistic. Fabulous. Okay, so the process of statistics, let's break it down a little bit more. When we're running an entire study with statistics, it has four main parts. The first part is to identify the research objective. Researcher must determine the questions he or she wants answered. The questions must clearly identify the population that is to be studied. So I want you to highlight that right there. Clearly identify the population. Number 2, we're going to actually collect the data needed to answer the question posed in number 1. Conducting research on an entire population is often difficult and expensive, so we typically look at just a sample. This step is vital to the statistical process because if the data are not collected correctly, the conclusions drawn are meaningless. Do not overlook the importance of appropriate data collection, and we will discuss that later in this chapter 1. We're going to then describe the data using descriptive statistics. That's going to be all through chapters 2 and 4. Then we're going to perform inferences on the data to apply appropriate techniques to extend the data, the results obtained from the sample to the population, and report a level of reliability. These will be happening through 5 and 8, and we'll get through some of the inferential techniques in 9 and 10. We won't make it through all the way through 15 in this textbook by the end of this course. So let's just kind of walk through the way you would set up an entire study of statistics. Example 2. Pew Research conducted a poll and asked, do you trust all or most of your neighbors? The following process allowed the researchers to conduct their study. Number 1, they identified their research objective. The researchers wanted to determine the percentage of adult Americans who trusted all or most of their neighbors. Therefore, the population was what? What is the population? All of what?
Adult American.
All adult Americans. We're trying to have some inference on all adult Americans, whether they trust their neighbor. Then they set about collecting the data. It is unreasonable to expect to survey the more than 200 million adult Americans to determine whether they trust all or most of their neighbors. So the researchers surveyed a what? What is it called when you get a smaller group? Sample, very good. A sample of 1628 adult Americans. Of those surveyed, 847 stated they trust all or most of their neighbors. So then they describe their data. Of the individuals in the survey, 52% stated they trust all or most of their neighbors. This is a blank statistic. What kind of statistic is that? Since it's just describing the statistic we got, it is a descriptive. Very good. The Pew Research then wanted to extend the results of the survey to all Americans. When generalizing results from a sample to population, the results are uncertain. This is because it's now an inferential statistic. To account for this uncertainty, Pew reported a 2.5 margin of error. This means Pew feels fairly certain, 95% certain, that the percentage of all adult Americans who trust all or most of their neighbors is somewhere between 49.5 and 54.5%. So that would be the process of running this entire study. Each of those steps is going to take a significant amount of time to actually conduct in real life. But what we're first going to worry about in this class, is besides the entire process, because that's getting us through the whole course, is we're going to work on data collection and how to choose the correct questions to ask in different scenarios. So we first need to distinguish between qualitative and quantitative variables. So variables are characteristics of the individuals within the population that vary. Obviously, variables vary. If variables did not vary, they would be called constants, and statistical inference would not be necessary. Variables can be classified into two groups, qualitative and quantitative. Have y'all heard those words before? So qualitative variables, or categorical variables, allow classification of individuals based on some attribute or characteristics. Qualitative variables describe an attribute or characteristic of the individual. Quantitative variables provide numerical measures of individuals. The values of quantitative variables can be added or subtracted and provide meaningful results. So numerical measures. Quantitative variables are numeric measures that have meaningful, again, we wrote that sentence twice, meaningful arithmetic operations. and can be performed on values of the variable. So let's just see first if we can categorize the difference between these types of variables. Let's say we're doing a study and we're looking at the variable of gender. Is gender qualitative or quantitative? Qualitative. And it's qualitative because it is a categorical. That's not how you spell that word. Categorical. Good. Classification. Categorical classification. How about temperature?
Qualitative. Yeah, qualitative.
Quantitative. Why is it quantitative?
Numbers.
Because it is numeric and arithmetic means something. Now, what do I mean by that? Arithmetic means something when it comes to temperature. Arithmetic means adding and subtracting. Let's say one day the temperature, well, what is the temperature right now? It is 35 degrees outside.
Something like
2 days ago, it was 80 degrees outside.
Yeah.
What's the difference between 2 days ago temperature and today's temperature? Is that a meaningful measurement? Yeah, we would say it has changed by about 40-something degrees. That has meaningful arithmetic, what word was I about to say? Meaning. Wow, thank you. So adding and subtracting these numbers actually means something. Okay, letter C, number of days during the past week that a college student studied. Qualitative or quantitative?
quantitative.
Very good. Why?
Numbers.
It is numeric. And we can add and subtract these numbers. Let's say I studied 1 day this day, or 1 hour this day, 2 hours next day. I add those together, that's 3 hours total. That has a meaningful meaning. So, and arithmetic means something. Okay, the last one. Zip code. Qualitative or quantitative?
Qualitative.
What's your final answer?
Qualitative. Sorry, I see.
Why would it be qualitative instead of quantitative? Isn't it a number?
Yeah, but you have it.
It's not really something you change.
Say, I just didn't hear you. I think I've.
Describing an area.
Yeah, you're describing an area. So it categorizes. Wow, I cannot spell anything today. It categorizes a location. And if you took one zip code and added it to another, would that mean anything?
No.
Yeah, so arithmetic is meaningless with this. That means it's qualitative. So it categorizes a location instead of being some numerical measure. And if we tried to add them together, it would mean nothing with zip codes. Wow. Ugh. It's a Monday. Except that it's Tuesday. Oh my gosh.
Well, so it's like 2 days after. We need at least a week.
You don't get a week. All right. The next thing we're going to do is distinguish between discrete and continuous variables. Because knowing what you're studying and what you're varying in your studies is going to help you eventually choose the correct type of study to perform on it. So we have to know the differences in these variables. A discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. So discrete means countable. The term countable means that the values result from counting, like 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between two possible values. So like 1.5 won't make sense. 1 and 2 make sense. That's a discrete variable. On the other hand, a continuous variable is a quantitative variable that has infinite number of possible values that are not countable. In fact, we're going to measure things, and those are going to be continuous variables, things that can be measured. So the difference is discrete, countable, continuous, measurable. Let's look at these examples. We're just going to decide if it's discrete or continuous. And then for fun, we're going to also tell the possible values. The number of heads obtained after flipping a coin 5 times. Is that discrete? Why is it discrete? Because we can countable. What? We can count it. For fun, let's list out all of the possible values. That's not how you spell that word either. Oh my gosh. If I flipped a coin 5 times, how many heads could I possibly get?
1, 2, 3, 4, 5.
Or even 0. Those are the possible values for this coin flip. How about the number of cars that arrive at a McDonald's drive-thru between 12 p.m. and 1 p.m.?
Continuous. Well,
I can measure it?
no, discrete.
Why is it discrete?
Good count.
We can count it. You wouldn't count half a car. It'd be either the whole car or no car at all. So what are some possible values here? So 0, 1, 2, 3, 4, 5, 6. This is getting annoying, isn't it? So I'm just going to go dot, dot, dot. There's no upper limit to this one. Because, like, what if 200 cars came through the drive-thru? Part C asks, is it discrete or continuous? The distance a 2019 Toyota Prius can travel in the city driving conditions with a full tank of gas.
Continuous.
Continuous. Why is this one continuous?
Because you can measure.
We measure it. Our possible values here are not going to be written as a set since it is continuous. So similarly to when domain and range in algebra was discrete with the dots, we just listed them out. Or continuous, now we just say that the distance is going to be greater than or equal to 0. This would be measured in miles, feet, inches, things that measure. That's going to be our continuous data. So let's kind of put this together and see where these variables come from in an actual set of data. The list of observed values for a variable is data. Remember that qualitative data are observations from a qualitative variable. Quantitative data are observations from a quantitative variable. Specifically, going on, discrete data are observations corresponding to a countable variable. And continuous data are observations corresponding to a continuous or measurable variable. The table on the right presents a group of selected countries and information regarding these countries as of July 2018. We're going to identify the variables, individuals, and data in the table. What are the individuals that we're looking at in this study? The countries, exactly. So my individuals would be Australia, Canada, France, Morocco, Poland, Senegal, and the United States. Those are my individuals in this study. What are the variables?
The population life expectancy.
Okay, population, life expectancy, and the type of government. Before we move on from this, let's categorize those variables. Which one of those is a qualitative variable? Government type. Which means the other two are what kind of data? Quantitative, because we're getting numbers that mean something when you add and subtract them. And then out of population and life expectancy, which one is discrete and which one is continuous?
Life expectancy would be continuous.
Life expectancy would be continuous,
And population would be discrete.
and population would be discrete. Now, why would population be discrete and life expectancy be continuous when they're both giving me decimal answers?
Because life expectancy, like, not everybody has the exact same age. Like, it doesn't stop at a certain age.
At like your birthday?
Yeah.
Okay, and why would population be discrete?
Because
Do you count half of a person? No. So it's either the whole person or no person at all. So that makes it a discrete variable because they're going to count as entire humans. Now the data in this table is all of the information that we can see. So for example, if we were looking at the data when it came to, let's, correspond to life expectancy, our data would be 82.3, 81.9, 81.9, 77.1, 77.8, 62.1, and 80.0. Those are the data specifically from life expectancy for these countries, for these individuals. So the data really are just observations in the table. So what we actually get for each of these variables through our study for each individual is the data. Is classifying variables that are quantitative, qualitative as a level of measurement. So here's the new type of classifications for these variables. I know there's a lot of vocabulary in this section. For qualitative variables, which remember are our describing variables, the first level that we can measure something at is called the nominal level of measurement, which is really just meaning we are categorizing it by name, by label, by type. It's like the basic level of measurement. The ordinal level of measurement occurs when you have all the properties of nominal, meaning you categorize it in some way. However, the naming scheme allows for the values of the variables to be ranked. So let's say that we are classifying something and this classification is greater than another classification. That is now an ordinal level of measurement. A variable is at the interval level of measurement if it has all the properties of the ordinal, which means it can be categorized and ranked, and the differences in the values of the variable have meaning. The differences in the value of the variable have meaning. Also, a value of 0 will not mean the absence of the quantity. So 0 means something. For quantitative variables that are measured at the ratio level, it has all the properties of the interval level and the ratios, this time, of the values of the variable have meaning. In this case, a value of 0 means the absence of the quantity at all. So for each of the following variables that we could study in a study, let's determine the level of measurement and explain our choice. Gender. How would we measure it? Would it be nominal, ordinal, interval, or ratio level?
nominal.
It is nominal. This is the basic one. This is nominal, and why would it be nominal?
The category.
It's used to categorize, but not rank. It's used to just categorize, but not rank the categories. How about temperature? Would that be nominal, ordinal, interval, or ratio?
Interval.
It is interval. Why would it be interval?
Just varies.
Well, true. They all vary. But specifically, what did I underline in the interval definition?
Differences.
The differences in temperature mean something, right? So if you have, again, like this, it's 60-degree day we had a few days ago and the 35-degree day we're having today, that difference means something. And if it's 0 degrees outside, does that mean that there's nothing outside, or does that mean that it is zero temperature? Zero temperature. So 0 has meaning. It's not the absence of a quantity. So we'll write down the differences in the values have meaning. And 0 degrees means something. How about the number of days during the past week that a college student studied? Nominal, ordinal, interval, or ratio? It's actually not interval. This one will be ratio. It's a ratio because, for lack of a better word, the ratio of two different measures have meaning. Meaning, if I studied for 4 hours and you studied for 2 hours, I studied twice as long as you. That's a ratio. And if I say I studied 0 hours, is that the absence of studying? Yeah. So 0 means the absence of something. Now what about the last one? The letter grade earned in your statistics class. Nominal, ordinal, interval, or ratio? Ordinal. Now why would this one be ordinal? Because it's ranked. Very good. It's used to categorize and rank. And it doesn't make it into the interval category because if we subtracted an A minus a B, does that mean anything? No, so the differences or the ratio don't mean anything, so we don't make it into the interval or ratio level of measurement. Ooh-wee, lots of vocabulary, yes? So for your homework today, you have your paper. I'm going to explain this before I move on. You have your paper, obviously, with the matching of the definitions. But if you look at part 2, it says complete the GIMKit linked there. And LOL, that means Google Classroom. So in your Google Classroom, there is a GIMKit that has been linked, and it's a homework assignment. You have to get 40 questions correct to be done with it.
So 2 hours.
I hope not. I hope it won't take you 2 hours to do. But it is a 2-part homework. The first part obviously is just getting the definitions here on your paper, and the second part is doing the GIMKit on your computer. Both need to be finished for this assignment to be done. Cool?